Good morning and welcome back to Dr. Logic Awkwardly Does Logic. Let's talk about truth. In propositional logic, it's very easy to determine whether a given formula is true on a single truth value assignment, but most of the time we're not actually interested in that. We are interested in a stronger question of whether the formula will always be true no matter what truth value assignment we pick. And if that happens, we say that the formula is valid, or that it is a tautology, so always true. Now, one of the things that's interesting about that is that it already starts you thinking about modal notions, because it's not just what happens to be true now, but what must always be true. So propositional tautologies are exactly the sort of thing that are going to be necessary. Hold that thought, because it'll come up in a number of different contexts going forward. But if we move to the modal setting, so we've got formulas that have modal operators in them, we may still want to be able to distinguish between kind of sentences that are merely true, or sentences that are always going to be true, or sentences that are always going to be true in a particular context. So this video is to give you a whole bunch more definitions about truth and validity and a variety of kind of scaled notions in between. So we will start from the very weakest notion and move all the way down to the very strongest. And we will do this with our handy dandy whiteboard, because we need to be able to see the differences between these different notions. So we will start off with the notion of satisfiability. So a well-formed formula phi is satisfiable if there is a model and a world in that model, and on that model at that world, phi is true. So if there is a model M and world W such that on that model at that world, phi is true, we will sometimes say if satisfiable, we will call it consistent. So it is possible for it to be true, is a way to think about it in a very kind of generic sense of possibility. Now, we can talk about being true at one world in a model, but we could also be interested in the formulas that are going to be true at any world in a model. So if we have one of those, so with phi is going to be called valid in a model M, if for every world in that model, phi is true at that world. So we've gone from truth at one world in a model to truth at all worlds in a model, slightly stronger. Often, though, we aren't so much interested in individual models, so frames that have a particular truth value assignment of the atoms across the various worlds. We're interested in the kind of structural properties of the particular underlying possibility space, i.e. the frame. So what would happen if we wanted to ask about a formula's truth on a frame, no matter what world it was at or what truth value assignment was used? That is the next stronger notion, and that is the notion of being valid on a frame. So a well-formed formula phi is valid on a frame F if it is valid in every model M on F. So now you can start to see how these definitions are increasing in strength, because each one is defined in terms of the previous one. The next one is, well, what if we're not interested in just one frame, but we're interested in any frame that has, say, a particular property? For instance, any frame where every world can see itself, or every frame where each world can see at least one world. So it can make sense sometimes to talk about individual classes of frames. And we can just generalize the notion of being valid on a frame to valid on a class of frame as follows. So well-formed formula phi is valid on a class of frames, and we'll use this curly C for it, if, what do you think? It's going to be valid on every frame in the class. Valid on every F in C. And then the very strongest notion that we have is the notion of just straight out validity, validity simpliciter. And this comes when we don't put any restrictions on the class of frames that we're looking at. We, in a sense, are looking at the class of all frames. So a well-formed formula phi is valid without any modifiers if it is valid on every class of frames C. So when we have this particular type, we will write the double turnstile followed by phi and nothing on the left-hand side. We have this notion of doing truth at a world, but we can expand this with our notion. So if truth at a world is written like this, validity on a model, we will just drop reference to the world. Validity on a frame, we will drop reference to the model. Validity in a class of frames, we will drop reference to the frame itself. And then you can see how we get to here. And this is just our normal kind of modal analog of the propositional notion of validity. These are, in a sense, the modal tautologies. This last type of validity, we will sometimes call K validity. And this is because our basic modal system that we will build to capture this notion of validity is due to Kripke. So there's going to be a lot of Ks coming up because Kripke was pretty influential in terms of the systems and the semantics, as we've already seen. So there you have it. A gradation from mere truth at one world and one model, and that is all that you need for a formula to be satisfiable, going down in successively stronger and stronger and stronger notions, so that loads and loads of things are going to be satisfiable and many, many fewer things are going to be valid. In the next videos, we will go through examples of proving validity or proving satisfiability or talking about invalidity, and a couple of nice corollaries stemming from all of the definitions that we've had so far. But we'll save that for next video. 5 definitions is enough for one. Take care and see you later. Bye.